welcome to our maths class. And today we are going to learn about circle geometry. I will simplify it so that everyone can easily understand it. And if you have any question or anything else to say, just feel free to type it in the comment section. So, to make sure that we all start at the same page, let us begin with the basic geometry of a circle. If you draw a circle, the border line of that circle is called the circumference, and the point found at the middle of that circle is called the center. A line drawn from the center of the circle to the circumference of the circle is called the radius. The line drawn from the circumference, passing through the center and ending on the other side of the circumference is called the diameter. A line drawn on only a part of the circumference is called an arc. A line drawn from the circumference and ending on the other side of the circumference without passing through the center of the circle is called a chord. A line drawn starting outside the circle and passing through the circle while also ending outside the circle is called a secant. A line drawn outside the circle while touching only the circumference of the circle but without cutting through the circle is called a tangent. An area enclosed between two radii of the circle and the arc is called a sector. An area enclosed between a chord and an arc is called a segment. Now, we now know the language of circle geometry, so let us now look on the theorems or rules of circle geometry. The first theorem states that angles subtended by the same arc or chord are equal. If we draw a circle and a chord, we will also get an arc. If we draw two lines starting from the same point on the circumference and touching the ends of the chord, we get an angle subtended by the chord or arc, or in other words, we can say that the angle is facing the chord or the arc. So let us call this angle x. Therefore, angle x is subtended by the chord or arc. If we draw a second angle on the circumference that is subtended by the same arc or chord, the value of that angle will also be x. If we draw a third angle on the circumference that is subtended by the same arc or chord, the value of that angle will also be x. Note that the theorem is still the same even if the chord is not drawn. Now let us look at some examples. We are given angle on the circumference which is 70 degrees and we need to find the value of angle r which is also on the circumference. So as we can see that the angle r and 70-degree angle are subtended by the same arc, it means r is also equal to 70 degrees. Let us also look on our second example, whereby we have three angles. We have angle x, 77-degree angle, and angle y. From the diagram, we can see that these three angles are all subtended by the same arc. Therefore, angle x is equal to angle y, which is equal to 77 degrees. The second theorem states that the angle at the center is twice the angle at the circumference, when they are both subtended by the same arc or chord. If we draw a circle with center O, then draw an angle starting from the center to the circumference, we can see that this angle is subtended by a certain chord and arc. So if we draw another angle at the circumference of the circle, which is subtended by the same arc and chord, and call this angle x, it means the angle at the center is 2x. Let us take a look on the following examples to see different situations in which we can apply this theorem. From these examples, we can see that the angle can be either acute, obtuse, or reflex. Now let us find the value of x on the last example. As we can see that our angle x and the 220-degree angle are subtended by the same arc, we now know that x should be half of 220, which is 110 degrees. The third theorem states that angle subtended by the diameter is 90 degrees. It can also be stated as angle in a semicircle is 90 degrees. So if we draw our circle and draw two lines starting from the ending points of the diameter and meet at any point on the circumference to make an angle, that angle will be 90 degrees, or we can call it a right angle. Now let us work out the following example. We are given a triangle ABC, which is in a semicircle. One of those angles is 40 degrees, and we are required to find angle x. So, based on the third theorem, we can see that the angle CBA is subtended by the diameter, therefore is 90 degrees. Since we know that angles in a triangle add up to 180 degrees, it means 40 plus 90 plus x equals 180 degrees. If we make x the subject of the formula, we can see that x equals 180 minus 90 minus 40. Therefore, x equals 50 degrees. The fourth theorem states that the angle between the tangent and radius is 90 degrees. So, if we draw a circle and draw a tangent at any given point, if we then draw the radius from the center of our circle to the point where the tangent touches the circumference of the circle, the angle that is formed will be a right angle, which means it is 90 degrees. Before getting to the example on the fourth theorem, I will start by explaining the fifth theorem, because it relates to the fourth theorem since they both talk about tangents, so the example will combine the principles of both theorems. So the fifth theorem states that two tangents on a circle that meet at a point outside the circle are equal in length. Let us draw a circle with center O, then we draw two tangents to the circle, which are coming from one point. Let us also draw two radii, which meet the tangents at the circumference of the circle. From this diagram, we can see that the two tangents are equal in length according to the fifth theorem, and also we know that the radii are also equal in length. The shape that we get here is a kite. Now, from the fourth theorem, we can see that the angles between the radii and tangents are 90 degrees each. Now we are left with two angles with unknown angles. We can just label them x and y. Since our shape is a kite, which is a quadrilateral or four-sided shape, we know that the interior angles in a quadrilateral add up to 360 degrees, but now we already have two 90-degree angles, which add up to 180 degrees, so it means x and y also add up to 180 degrees. If we draw a line from the point where the two tangents meet to the center of the circle, this line will be a bisector to our kite, which means it divides the angles x and y into two equal parts. So we get half x and half x, then half y and half y. Now, let us work out the following example together. We are given this diagram, and we need to find the value of the angle x. Now, from the diagram, we can see that DA and DC are tangents, and if we join them with the two radii, we form a shape of a kite, which is AOCD. So we can see that angle ADC and AOC add up to 180 degrees. Since we are given angle ADC as 44 degrees, we can calculate angle AOC by subtracting 44 degrees from 180 degrees, then we get 136 degrees for AOC. We can also see that angle AOC and angle x are both subtended by the same arc. So since angle AOC is at the center and angle x is at the circumference, we can now apply the second theorem, which says angle at the center is twice angle at the circumference. So angle x is half of angle AOC, which is 136 divided by 2. If we divide, we get 68. So angle x is equal to 68 degrees. Let us do another example together. We are given this diagram, and we are supposed to find the angle ODC. So we can start by the procedure that we did from the previous example. We have our kite, a bod, and we can see that angle BAD and angle BOD add up to 180 degrees. So BOD equals 180 degrees minus 40 degrees. Therefore, angle BOD equals 140 degrees. We can also see that angle BOD and angle BCD are subtended by the same arc, so we can apply the second theorem, which says angle at the center is twice the angle at the circumference. So angle BCD equals 140 degrees divided by 2, which is 72 degrees. Now we want to calculate angle OBC, but remember from the fourth theorem, we know that angle between tangent and radius is 90 degrees. So OB is 90 degrees. For us to get angle OBC, we subtract 75 degrees from 90 degrees. Then we get angle OBC as 15 degrees. Now we need the reflex angle BOD, But since we already have the obtuse angle of BOD, which is 140 degrees, we can simply say reflex BOD equals 360 degrees minus 140 degrees. So reflex angle BOD equals 220 degrees. Now finally, we can calculate our angle ODC. We can see that the shape OBCD is a four-sided shape, hence it is a quadrilateral. We know that angles in a quadrilateral add up to 360 degrees. So angle ODC equals 360 degrees minus the combination of 15, 220, and 70. If we do this calculation, we get our angle ODC as 55 degrees. Now, going to the sixth theorem, the theorem states that angle between tangent and a chord is equal to the angle in the alternate segment. If we draw our circle with center O and draw two angles subtended by two chords, although the shape is of a triangle, but I need to focus on the angles. So if we draw a tangent, we can choose one angle between the tangent and the chord and label it x. So if this angle is x, therefore the other angle facing this angle, or at the opposite side of this angle, that is the angle in the alternate segment. So this angle will also be x. Also, suppose we choose to label this other angle y, then this angle also on the opposite side is y. Now, let us look at the following example. We are given this diagram and an unknown angle y. So to find, we just use our theorem. We just have to look for the angle on the opposite side of the angle y, off which, in this case, this angle is 43 degrees. So, the angle y is 43 degrees. Now, moving on to the next theorem. That is the seventh theorem. It states that opposite angles of a cyclic quadrilateral are supplementary, which means they add up to 180 degrees. If we draw our circle, and in this circle we draw a four-sided shape, that is a quadrilateral. But take note that all the vertices or corners of this quadrilateral should be on the circumference of the circle, for the shape to be called a cyclic quadrilateral. So if we label this angle x, and the opposite angle we label it z, therefore x plus z equals 180 degrees. Also, if we label this angle w and the opposite angle, we can label it y. Therefore, w plus y equals 180 degrees. Once again, just as a reminder, take note that all the vertices of a cyclic quadrilateral should lie on the circumference. Let us take, for example, suppose we have this shape with angles x, y, z, and w, with the vertices O, A, B, and D. This shape is not a cyclic quadrilateral since the corner or vertex O is not on the circumference of the circle. Therefore, this theorem will not apply at all to this shape. So to make a cyclic quadrilateral, we need all the vertices or corners to be on the circumference of the circle. So if we add D, then the shape can be a cyclic quadrilateral. Let us now do the example, which is related to this theorem. We are given this shape, which is a cyclic quadrilateral, and we are required to calculate angle M and angle N. So in this case, we simply apply this theorem, knowing that the opposite angles in a cyclic quadrilateral add up to 180 degrees. Therefore, angle M plus 100 degrees equals 180 degrees. So angle M equals 180 minus 100, which is 80 degrees. We do the same procedure for angle N. Angle N plus 70 degrees equals 180 degrees. So angle N equals 180 minus 70, which is 110 degrees. Now our last theorem, which is the eighth theorem, states that exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So if we draw our circle, and inside the circle we draw a cyclic quadrilateral, with one side which is extended outside the circle, this extended side will make the exterior angle. So if we call this angle x, therefore the interior angle, which is on the opposite side, will also be x. Now, let us look at an example to apply this theorem. We are given this diagram with a circle, and inside the circle we have two cyclic quadrilaterals, which are PQRT and PQRS, but we can see that the given exterior angle is for the cyclic quadrilateral PQRS, so the angle 112 degrees will be equal to the opposite interior angle of the cyclic quadrilateral, which is angle PQR. Thank you so much for watching. I hope this video was very useful to you. And once again, if you have any comment or question, just feel free to type it in the comment section. And don't forget to like, share, and subscribe. I wish you all the best.